All right. So how do you approach a robotics project? Okay. Before we kind of discuss this, I just have a couple of caveats to kind of lay out there. Number one, like what I'm going to discuss right now is not stuff that are set in stone. It's basically how I approach a problem, right? So it's completely up to you to kind of approach the problem in any way you want to approach it, right? So this is based on my experience. There's nothing to say this is exactly how you should do it, right? So it's just basically one way of doing it, and it's up to you guys to either take it or leave it, right? But I thought for some of you who are kind of lost, this is a good way to think about a robotics problem, right? So obviously we have the robot, right? And what we're going to do first, the first thing you need to do is break down the problem, right? Break down the problem. Right, so this robot could either be hardware or simulation, right? So obviously, since we're all in quarantine, we're going to use the simulation. So the first problem that you need to solve is setting up the hardware, right? So that's the first problem you need to solve, right? So either if you were working on actual physical hardware, you'll have to kind of take that hardware and get it running and see how it works, set up the ROS packages, all that stuff, right? In the case of a simulation, it's very similar. You set up the simulation, you look at what the ROS packages are for that, you set up ROS and all that stuff, right? So the first thing you need to do is set up your hardware or your simulator, right? And basically be comfortable about how it works, basically how you can set it up, and just get it working first, right? Next, obviously, the hardware has a bunch of sensors, or the simulation has your robot has a bunch of sensors. So the next problem you need to really solve and think about is getting information from those sensors, right? So you need to get information out of the robot, right? So again, so let me actually break this down into different problems, right? So the second thing you need to think about is getting stuff out. Get stuff out of robot, right? So again, ROS makes this super easy, right? You just need to subscribe to the right topics, right? So for example, if this is a camera or something like that on your robot, you need to use ROS subscribers to listen to the sensors that you want to, listen to the information that you want to, right? And you need to see if you can get this, like you need to be able to get this information out of the robot, right? So that is the second problem you need to solve. You need to look at, okay, what are the sensors that are in my robot? How can I get the information that I want out of the robot, right? So the next step is, and this is the important, one of the most important parts, right? And this is where you probably have to spend a lot of your time, right? You need to process that information, right? So this is where the bulk of your project is going to happen, right? So you're going to get this information out of the robot, right, using ROS, and then you're going to actually do something to that data. You're going to either detect something, or you detect something and then decide what to do, right? All of that kind of logic goes in this process, right? And this is where you'll be spending a bulk of your project in, right? And this can either be done in MATLAB, right, C++ or Python or whatever, right? But what we suggest is use MATLAB, because most of what you learned in this course was done in MATLAB, right? So if you want to do feature detection and things like that, it's easier if you use MATLAB, but you're free to use C++ or Python, in which case you'll have to use OpenCV and all sorts of stuff, right? But that's really up to you. But my suggestion personally is that since we learned a lot of MATLAB this course, use MATLAB for this, right? So listening to this ROS information and getting into MATLAB is a kind of a mini problem that you'll also have to think about. So getting stuff out of the robot, I'd say there's another problem associated with that, which I'm going to call problem 2.5, which is get it into MATLAB. Right, so usually you do that using something called ROS Bridge, right, which connects MATLAB to ROS, right? So when you set up your simulation, it will be constantly publishing information, right? And then using ROS Bridge, you can listen to that information, get that stuff into MATLAB, so that you can then process it in any way you want, right? But that's obviously not it. You need to, after that, use that information and do something, right? Like you need to actually implement something in the robot. It's not just enough to listen to it. You need to get the robot to do stuff, right? So then from this point onwards, you need to basically get the robot to do stuff, right? So I'm just going to say do stuff, right? Right, so that can be achieved using ROS publishers. Right, again, you'll have to use MATLAB's ROS Bridge to do that, right? 3.5, basically MATLAB again. If you're using MATLAB, that is, right? If you're using C++, this step 3.5 and 2.5 is irrelevant, right? So essentially, what you do is then try and get your robot to do stuff, right? So the reason I call this number 3 and this process number haven't named it number 3 is because these 3 steps, right, will probably be the first things you do, right? Because first you need, before even processing information, you need to be able to listen to the information coming from the robot, right? You need to obtain that information and kind of visualize them or get them into MATLAB or whatever, right? So once you set up your simulation, that's going to be the second thing you do. You try to get that thing, basically get information from the robot into MATLAB so you can process it, right? And then I'd say even before processing that information, see if you can get the simulation to do stuff that you want also, right? So what I'm suggesting here is do these things in a modular fashion, right? Like listening to the robot and doing stuff, like you can do them independently of each other, right? For example, if you want the robot to travel to a certain location, see if you can kind of hard code those values and publish them to ROS and see if you can get the robot to go to where you want it to, right? Even before processing the information, you can not worry about this stuff and think of this in isolation, right? See if the robot can go to a place that you want it to get to, right? So even if it's a robot arm that you're thinking about, right? See if you can publish information back into this simulation and get it to do stuff, right, that you want it to. Even before thinking of this process part, like how to decide what to do, you kind of hard code values, test it and try and get that working, right? Because what you do is if you can get this part working and this part working, right, then all you have to worry about is this part, right? The process. How do I kind of process this information that I'm getting and get it to go to where I want it to, right? So always think of the problem in a modular kind of way, right? Try and achieve these things separately, right? And then finally, think about the fourth part, which is the process, right? So set up your simulation, see if you can get information from that simulation into MATLAB, right? And then see if you can, from MATLAB, publish actions to the robot and get the robot to do things that you kind of envision it to do, right? And then figure out how to kind of bridge the gap between the information that you're getting in and what you want the robot to do, right? And remember that this fourth part is where you'll have to spend most of your time, right? So try and get 1, 2, and 3 done as soon as possible, right? Like ASAP. And just remember, the reason we are doing this in a modular way is because at each of these steps you will struggle, right? It's not easy, right? Since you're doing this for the first time, in each of these steps, right, there will be a learning curve, right? So what you do is, instead of attacking this problem as a whole, which will be really difficult, you break them down into mini problems, right? And try to tackle a small problem at a given time, right? That way you get good at one of these parts, and then you can kind of progress. The next thing, you can even break this process part into further sub problems, right? So this process number 4, you can break this down into sub problems, so 4.1, 4.2, 4.3, and so on, right? And that way what you can do is you can kind of break them down into smaller problems and kind of try and tick them off one by one, right? And always try to approach it in a modular way, right? So that once you do one of these, they should be able to kind of behave independently of each other. So breaking down a problem like this makes it super easy to approach it, right? But make no mistake, each of these steps you will struggle, right? But at least it's like you won't have to deal with the whole problem as a whole. It's kind of like you try to achieve one of these sub problems at a time, right? Which makes it so much more easy, and it also keeps you motivated, right? Because you're seeing yourself progress through this, right? And by the end of it, you'll hopefully complete this entire loop, right? So the next thing you need to do once you break this problem down is you need to set a timeline for yourself, right? And that's super important because right now with the quarantine and stuff, time is really fluid. It's behaving really weirdly for all of us. If you notice, like, the days finish really quickly, and then you look back 1 week, but the week feels like a month, and like everything is kind of like screwed up at the moment, right? Which is why it's super important that you set up your really good timeline for yourself, right? Where you kind of break down these problems and say, okay, in week 1, I'm going to do problem 1, 2, and 3, and get those working, and then week 2, I'm going to start working on this and sub problem this, and kind of plan out your entire project once you break down the problem, right? Since if you're working with teams, you can delegate certain parts to different people and tell them, okay, this is when you want this part to be completed on, and so on, right? And set yourself realistic timelines, and also always make sure that you give yourself enough time, right? Because whatever said and done, even if you set things in your timeline, since this is robotics and things always go wrong, and you're working with software, open source software, and this is the first time many of you guys are approaching a problem like this, what is going to happen is, it's going to be more difficult than you think it is going to be, right? So give yourself plenty of time and plan ahead, right? So I'd say once you break down the problem, set it up in a timeline. And the third and most important thing is stick to the plan, right? I know that might seem obvious, but this is where like discipline, right, and focus comes into play, right? Because especially right now, right, it's really hard for all of us to kind of stay focused with all of the crazy shit that's going on. But it's really important to create a sense of discipline, especially these days, right? So every day chip away at a different part of the problem, allocate like 2 to 3 hours a day or something like that, like plan it out and build that sense of discipline, and kind of slowly build it up over the next couple of weeks, right? And also realize that when you start off, it might be a bit difficult to get that rhythm going, but if you start creating a habit, as in like 2-3 hours every day, and slowly ramp it up as you go along, you can kind of, it's like going to the gym, right? You start off with like smaller weights, and then you kind of increase the intensity, right? So it all comes down to like habits and creating that discipline and focus so that you kind of stick to the plan that you create, right? So take this week, break down your problem depending on your project, and try to approach each of these different aspects of it and create a plan for the next couple of weeks, and make sure you stick to the plan. Don't wait till the last minute, because whenever you're dealing with like robotics, trust me, it's like Murphy's Law, right? Like things will always go wrong, right? So the more time you give yourself, the better things will be. Because trust me, it's already going to be pretty frustrating. but it's going to be even more frustrating and difficult if you wait till the last minute, right? And we've seen this over the last couple of semesters. Like, groups that do really well are not necessarily the smartest. It's just people who start early, right, and work on the problem little by little. And because trust me, like, this might seem like a really difficult problem, but there's plenty of resources online. We've given you a lot of information about sensors and controls. Like, for example, all the sensor stuff we discussed kind of fall in this part of the equation, right? And then all the control stuff that we discuss kind of fall in this part of the section, right? So sensors is basically getting the information, processing that, and then the control part is basically getting the stuff back into the robot. And another small note about control, right? Most of the platforms that we are working with, like the Turtlebot and the Fetch, right, already have controllers in them, in the ROS packages. So the chances are you don't have to design a LQR controller or a PID controller and things like that, right? Chances are most of your ROS packages already have these low-level controllers in them, right? So for example, if you want it to go to a certain place, it will go to it, right? But it's up to you. Like, if you, so in a certain way, you guys are lucky. You don't have to design controllers from scratch, which usually is a really difficult process, right? I mean, designing a LQR controller can be a project in and of itself, right? Or even pole placement, like how do you decide the poles? You'll have to model your system and so on, right? But then you might be asking, like, why are we learning all this control stuff? Because as like robotics engineers, you need to know what these controllers in your robot packages are doing, right? And if you want to kind of incorporate a small controller in your project itself, like, that will be great as well, right? Because most of these robot packages, although they have controllers already inbuilt, they also have the raw data that you can kind of control yourself if you want to, right? So if you want to, you can design your own controllers here. There's nothing stopping you from doing that, right? But if you don't want to, you don't have to either, right? Because the most of these platforms we're using already have motor controllers and all sorts of stuff in it. So in most cases, you just have to set the reference and it'll do what you want it to do, right? Which is basically some sort of ROS topic, right? But yeah, if you want it to be part of your project itself, that might, like, you can design a controller yourself. All right, so but yeah, so we're learning all this control stuff so that you know, if someone asks you, okay, this is how a controller really works, and maybe at some point in the future you might have to design a controller from scratch, in which case it will be useful information for you guys, right? But yeah, another important thing to understand is that, right, you guys might be kind of sad, like, you don't get to work on hardware and things like that, but the great thing about ROS is ROS really disconnects this section, right? Let me use a different color. Yeah, it kind of disconnects these two sections, right? So everything that you do here, right, if you've designed it in a way where it's using subscribers and publishers, it doesn't matter whether you're using hardware or simulation, because from ROS's perspective, you're still subscribing and publishing the same information. So at if some point after this quarantine ends, you want to actually test it on a physical hardware, it will still work, right? So from ROS's perspective, it doesn't matter whether it's a hardware or simulation, right? Which makes it pretty cool. So if you ever get the chance to test your algorithms out in hardware, it'll be pretty cool. Okay, so I'm getting a question. Are we able to use existing ROS packages and MATLAB libraries to assist in tasks such as object recognition and object orientation calculations? Are we expected to program these functions ourselves? No. So yeah, you can use all the MATLAB libraries. I mean, everything that we learned, right, like SIFT, SURF, feature detector, all that stuff are like complex algorithms, and you don't have to kind of program those things from bottom up. Like, you can use the libraries that exist, right? So feel free to use the functions and libraries that we learned already, or whatever you find online. But obviously, you don't copy and paste someone else's entire project, right? You need to adapt these libraries and functions into something novel and interesting. So I saw some of your like project proposals and stuff that are pretty cool, like ideas, right? So yeah, you can use already existing standard libraries, but obviously don't copy and paste someone else's entire code or whatever, right? The different components, obviously you'll have to use already existing stuff. Like for example, even today, like when we use these like SS function and all that stuff, right? There is like like these functions are underneath more complicated, right? But we don't want to spend time reinventing the wheel. Someone has already done this for us, so that we can do higher level problems, right? So you don't have, for example, have to create a feature detector from scratch, right? There are already stuff to do that, but what you use that feature detector and what you can do with it is up to your imagination, right? So in essence, you don't have to reinvent the wheel, but what you do with those libraries and functions has to be something kind of novel and interesting, right? So I hope that answers your question. So yeah, I hope this was helpful. Just remember, like, if you're finding it difficult to be motivated during this difficult time, just remind yourself, like, what you're doing is actually pretty cool, right? You guys, by the end of this semester, would have designed a robot, which is pretty awesome. Like, how many people do you know get to do that, right? So you guys are pretty lucky. Use this opportunity to learn how all of this works, and by the end of it, you will have a sense of achievement. And it'll feel pretty cool that you guys designed a robot from scratch, right? So good luck, and if you guys need any help along the way of like how to kind of break this down even further for your projects, just feel free to message me or whatever. All right, so having said that, let me save this. I'll put this recording up as well if you want to watch it again.